So running Elasticsearch as a service. So first off, how many people are actually running an Elk stack or have some form of Elasticsearch running? Yeah, pretty much everyone, I guess. Awesome. So that's exactly the thing. I'm from eBay Classifieds Group, and we're basically responsible for all local classified sites of eBay. Biggest notable ones are Kijiji in Canada. Not sure if you know it, but like Marktplaats in the Netherlands, eBay Kleinanzeigen in Germany. We're pretty much all over the place. And these are just platforms, external platforms, right? To support all features on these sites, we also run a ton of internal platforms which back all kinds of features. A lot of those features use Elasticsearch. So all those platforms are pretty much using Elk stacks, but not just that, we use Elasticsearch also for core search. So one of the things that we started noting is that with all this dispersion in geography, a lot of people are actually reinventing the wheels, setting up their own Elasticsearch clusters, adding monitoring, setting up alerting, dealing with best practices. And a lot of the times people were doing this with configuration management. And I don't know if you've ever dealt with setting up Elasticsearch using Puppet or any type of configuration management, but it can be quite a hassle, especially once you start going with upgrades or multi-version clusters managed by the same configuration management repo. It's gonna get really tricky. We thought, well, let's have a look at generalizing this. We run our own private cloud. All these platforms are supposed to migrate to our private cloud somewhere this year and next year. Which opens up possibilities to start running shared services, basically capabilities. Well, one of them was pretty obvious, which is Elasticsearch. We've been using it all over the place. Basically we started looking into what was required to run this. So there were basically a couple of goals, right? We wanted to achieve with running Elastic as a service. We wanted first, obviously, to simplify cluster management. Wanted to be able to do very easy upgrades, deal with availability zone maintenance, prevent basically reinventing the wheel, spending a lot of time in operations, dealing with all various components of monitoring Elasticsearch. We wanted to reduce time to market. So imagine we run a whole lot of experiments, right? To get very quick feedback on if our new features are going to be successful or not. And we leverage Elasticsearch a lot for a lot of those features. But if we rely on core search, our core search platform, running Elasticsearch, introducing new features there, and something goes wrong or a couple of bad queries snuck in and you basically tear down the Elasticsearch cluster, everything is affected. So we wanted to make sure that we're easily able to create new clusters and scale them out. The other thing, obviously, is centralized expertise. We have so much people dealing with the same things, but their primary focus isn't running Elasticsearch. Their primary focus is running their sites, and Elasticsearch plays a role in that, right? Obviously, automatic healing. We just heard the talk from Seth about being able to sleep at night. Automatic healing is definitely a thing we were looking for. Scalability is the other issue, right? We wanted to be able to scale out very quickly. Sometimes you just run into back queries or all of a sudden you get a surge in traffic, which you didn't expect during the day after your deployment, and you want to be able to scale out quickly without reverting any applications. Of course, security is definitely an issue in this. Sometimes there's some PII data in there. We want to be able to separate concerns. We want to be able and prevent other people accessing your cluster, dropping indices and that kind of stuff. So obviously, starting out, setting up an infrastructure, you need some kind of machines running. So we've been using Terraform to manage our cloud resources. In the case of Elasticsearch as a service, as you can see, it's a very simple repository. It basically consists of running we use Salt Stack for our configuration management. So we run one Salt master. We run a couple of Fabio nodes. For anyone who doesn't know, I'll get back on that. We run Consul, obviously, and Nomad. And that's pretty much it. On top of that, we're going to run pretty much everything. So I'm going to do a pretty unconventional thing. Normally, you talk about how do you get to deal with certain problems and then demo what you've built. I didn't want to rely on the demo gods because, pretty anxious to be here. So I made a video which basically demos a complete setup from nothing to a complete setup, opening up Kibana with a running cluster. So here you have like my Terraform repo for my dev tenant. I'm gonna pull in some modules. And here I'm gonna do a make apply. I use a make file in here just because I wanna have the single click experience. So instead of like, going after like waiting for everything to come up and refreshing pages, I just have a while loop running which actually checks if the endpoints are up or not. So that's happening right now. And you'll see OK, and that automatically opens up my browser and opens up Kibana, which means now I'm running already an ElasticSearch cluster, latest and greatest with, well, you'll see now, a couple of components in here. Set the refresh rate lower so you can guys see a bit earlier. So in here you have an overview of nodes. I'm not sure if you guys have been running 5.x Elasticsearch stack, but the new Kibana is pretty awesome. It embeds pretty much all the separate stacks in one, so you get an overview of machine learning, timeline, graph, and monitoring in here, which is quite nice, especially when you're running stuff as a service. So you'll see here, there's an overview of pretty much 3 client nodes, 3 data nodes, and 3 master nodes, and they are annotated with allocation IDs for Nomad. They show the worker which they're running on, the physical worker, and which availability zone they're running in. So here you'll see, filtering out master. Obviously the active master is the one with the star. The client nodes basically are doing nothing but forwarding requests and doing sorting and aggregations for queries. And here's HashiUI, so basically I deploy an entire HashiStack, and so far, because of the announcement of Hashi, the Nomad UI, there wasn't an alternative, so I've been using HashiUI to interact with Nomad cluster for very basic tasks like get an overview of cluster health, and in this case also increase task group counts, which I'm going to do right now. So I'm going to show like this upgrading the cluster. So let's say you want to upgrade, like you're running something, you want to increase capacity. This is one way of doing it. You go to HashiUI, you increase the node count of data nodes, which is happening right now. And then we'll go back to Kibana and we'll see like waiting for a bit. It takes a while to start up a Java application, especially Elastic. So you'll see after refresh, there's 3 out of 9 nodes total. Now there are 4 data nodes. And next refresh is 5, and then there's going to be 6, obviously. So this is pretty awesome. Like this shows like already the power, how quickly we can scale out and create a new cluster, right? And this was like completely from the ground up, just setting infrastructure, everything around it. Obviously, we don't have that in production running. We just have a massive amount of resources which are available. So spawning up new clusters is a matter of seconds instead of like just under 4 minutes to build the entire infrastructure. I'm just going to show like, this is a Consul UI, just show the amount of services which are running, and this is the Fabio UI, which basically shows how we route traffic to different clusters. So we have 2 Kibana nodes and we have 3 client endpoints, right? And that's pretty much it for, obviously quite important. Everything is SSL enabled. So we run an internal service called EasySSL, which basically generates certificates for us, renews them automatically. So every endpoint we have in here is by default encrypted with TLS certificates provided by Let's Encrypt. And this was a total runtime of 230 seconds. Cool. So when you start like building this out, like you're gonna have some challenge. You're gonna face some challenges which you need to overcome, right? And it doesn't just apply to Elasticsearch. This is like more general problem if you're gonna run like software which you don't control, like Elastic or maybe Cassandra or Kafka or whatever. There's not much, like it's not like you can easily fork out and change to your specs and then compile and maintain it yourself, right? So there's a couple of things you're gonna face, and I'm gonna go through every challenge in detail and then focus on how each component solved the specific challenge. So obviously we have a problem of discovering Elasticsearch master nodes, right? If you start up a container, you need to figure out where your Elasticsearch master nodes are, because that's the way Elasticsearch works, right? It keeps cluster state with all the nodes in there, index settings, everything. And the only way to join a cluster is basically contacting the master, getting an active state, and be aware of where your nodes are. Then there's obviously the problem of directing traffic to the correct cluster and Kibana. Internal traffic as well, like if we run Kibana from the cluster, then we need to figure out where to find the Elasticsearch client nodes. Then there's port conflicts, right? So you can't just run every node, every Docker container on port 9200, so you're gonna use dynamic ports for it. Obviously, a big chunk of this problem, like running something stateful on a scheduler, is data persistency. You want to control resources, like you don't want to over-allocate one cluster and then tear down the other one. You want to deal with hardware outages, authentication, and you want to enforce customer encryption. Allocation placement is also a different thing. Like I just showed, there's separation in availability zones. I'm going to get to that. So these challenges can all be solved with just these components. We are using Fabio, which was built by a colleague of mine, or ex-colleague of mine, for basically dynamic load balancing, zero-conf load balancing. We use Consul for service discovery, obviously, Nomad as a scheduler, and Docker, obviously, a component, pretty big component in here because we run our containers, with Docker. So the discovery challenge, right? We want to be able to discover elastic master nodes, and we want to resolve the problem of port conflicts. If you run something on dynamic ports, it's not like traditional configuration management where you can point something to an IP address and static port and then figure out where your master is. Fortunately, someone built a console-based discovery plugin for ElasticSearch. So basically you have Zen discovery for the part on startup to figure out where the masters are, and that's extendable with plugins, and someone wrote a native one for Consul, which means on startup we can just query Consul for healthy master nodes and figure out where to find them. That obviously also solves the problem with dynamic ports because they're registered in Consul, which means you already have the port. Next challenge is dealing with traffic, right? You want to make sure that you direct the correct traffic to the correct cluster. You want to enforce TLS encryption. And again, you want to deal with port conflicts. If you have an endpoint posting your data to ElasticSearch client nodes, you're not sure where they're going to run. Fabio solves it. It just has an SSL and HTTPS endpoint. Like we connect to it like HTTPS and then client endpoint. And Fabio directs it to the correct client nodes, depending on whatever you supply as an endpoint. The way that works is, I'm not sure if everyone here has some experience with Fabio, but Fabio is basically a zero-conf load balancer. The way it works is you register a service in Consul and you provide a special tag called URL prefix. And basically, based on the tag, Fabio knows, oh, this is a service I need to pick up and put in my internal routing table. And obviously, it only ends up there when the service is healthy. So a Consul health check is passing. So here you can see, like, on the left side, you see Elastic Client Node job configuration from Nomad. And I supply a URL prefix tag, which basically consists of an endpoint where my client nodes are going to live, which means it starts up, registers in Consul with URL prefix. Fabio sees it's healthy, it creates an internal routing entry, and knows how to route to it. On the other side, you'll see Kibana. Kibana obviously also needs an access point, like an entry point. So same thing there. We have a URL prefix exposing the front end. And then comes a more difficult challenge. Kibana obviously runs in a container somewhere, but needs to connect to its own cluster. Right? You run a single cluster for, I don't know, one of our platforms like Marktplaats, and you want to make sure that Kibana can connect to the client nodes. So the Docker container of Kibana uses environment variables to configure basic stuff. One of the things is the ElasticSearch URL, which is basically the same URL as the URL prefix on the client nodes. So we basically point Kibana back to Fabio, back to the cluster. And why I do that is because it greatly simplifies the architecture. You don't have to run something else just for different traffic purposes. You just have a single Fabio cluster routing everything, including internal traffic. And that's what you can see in this picture as well. This is basically the entire architecture of running Elasticsearch as a service, the way we do. Like on the right bottom, you'll see a Nomad client node, which runs a couple of Docker containers. There's a Fabio node, which is responsible for terminating HTTPS, and then connect HTTP traffic to the correct nodes. And obviously, Kibana connects back to Fabio through HTTPS to connect to a client node. So this is a very basic architecture if you compare it to a lot of, we've been experimenting with Elastic Cloud Enterprise, and this is so much more basic in design than the components required to run your own stuff in there. So I love the simplicity of this. Next challenge, obviously, is data persistency. Like we store documents in ElasticSearch, you don't want to lose the data all of a sudden, right? Nomad in 0.5 announced the concept of sticky ephemeral disks, which basically means you can mount an ephemeral disk with a sticky flag set, and Nomad will does a best effort to basically schedule an allocation back to the existing node and attach the volume back to the new allocation, which means like if you were not using ephemeral disk like this and you were to stop the entire job for a cluster upgrade or something went down and you lose, you want to perform some maintenance, you start up basically the job, but you lose the data, which is really not what you want. So that's definitely one thing that was really a requirement to run this. The other thing obviously is control resources. It's a scheduler. You can configure C group resources to make sure that we don't overutilize, or some clusters overutilize resources on a specific node. Obviously hardware outages and any other type of outages are dealt with automatically. I've been checking out our production cluster, which we've been running for a while, and at some point this week, some client nodes went belly up. JVM usage went through the roof. The ohm killer stepped in, killed the node, and no one even noticed. It got spun back up in a couple of seconds. Logstash just started, ingesting back again, and no one even noticed that there was a small outage. Obviously, port conflicts. Nomad is the authority for the process, including assigning resources, including network ports. So obviously, Nomad has a big role in that. The other thing is allocation placement. This is quite hard. If you have to deal with something that requires quorum, either it be Consul or Zookeeper or ElasticSearch or any type of node which has some form of leader election going on, because writes are quite hard to do in parallel. There's the problem of making sure to distribute the resources and the master nodes. So what I did, instead of like relying on constraints or whatever, I created a job file basically per availability zone. So our failure boundary in Nomad is an availability zone. Our DC is an availability zone, which means I can set up a constraint to always run a specific node count in a specific availability zone. The flexibility of this is that if you do a maintenance, like an upgrade, for example, rolling upgrades are now very easy. I do shard allocation based on availability zone, which means shards are distributed across all the availability zones, and I can stop an entire availability zone at once, upgrade that entire availability zone, get it back up, wait for cluster state green, go on to the next one. Which means like an upgrade, depending on the size of data and obviously the amount of writes since you stopped the job, can take anywhere from 10 seconds to 10 minutes, but it's really fast. The other challenge, obviously, is dealing with security, right? Security is a big thing. Like if you're running some form of shared services, you want to make sure that no one can access your resources. You want to make sure that no one can kill your cluster. A lot of people were doing endpoint protection using reverse proxies. These days, Elastic with the ElasticStack since 5.x has called a security plugin. It used to be called Shield, but these days Elastic Security, part of the default XPack installation. This is an enterprise feature though, so like this is not something you can run yourself in open source, but it's definitely very convenient for these types of setups. So on the right side, you'll see there's pretty much an LDAP configuration for security. This is just like we embed this in a Docker container. This is our default setup. You'll see that there's an unmapped groups as roles directive, which is set to true, which means like every time you create a new role in Kibana, it maps to, the name of the role is mapped to an LDAP group. So every time I run a new cluster for a new, like one of our platforms, they have their own LDAP groups, which are probably, maintained by themselves. And this empowers them to basically set up their own LDAP groups without my interference, creating new roles through Kibana, setting up the correct authorization and authentication rules, and without any interference, they can manage it themselves. So just looking at like the challenges right now, if I were, an overview of all the challenges we've dealt with, this has pretty much marked every checkbox like we faced. Obviously, Nomad, like a lot of people are skeptic about running some form of persistent data on a scheduler. And I agree with that. I wouldn't run my primary database without any form of, source of information, like where I can retrieve the data if something goes wrong. Obviously, Elastic is a different story. Elastic replicates by itself. It's fault tolerant by itself. You can up the replica count to, especially with search workloads, you're going to probably run more replica shards than primary shards. So it's fairly safe to run, in a setup like this. But then there's configuration management, which I still wanted to have a small chat about. Obviously, we've been trying to reduce the amount of configuration management in our setups. We basically were at a point in our Puppet configuration and repository where we spend almost 2 hours, and on average, or maybe 3 even a day, doing Puppet changes, testing them, making sure they didn't impact too much, and like we were in a bad place. So we recognized that, and when we started moving to the cloud, we started changing our configuration management tool. We went from Puppet to SaltStack. It's still debatable if that's the correct choice or not, but it was a clean slate for us. So basically, we reduced our configuration management all the way down to very simple thoughts, like configuration management is nothing more than installing a package, deploying a configuration file, reloading a service. And if you consider that like in all its ways, then you don't require all these special semantics which are offered in the Puppet DSL or Chef or any alternative. So yeah, in our situation, we still use configuration management, but in a very light way. We don't want to end up with, again, this is obviously an opinion. A lot of people think differently, but immutable infrastructure, in my opinion, is still very hard to deal with. Like, the amount of time required to build new images, upload to hypervisors, and just for very small changes, maybe a Fabio upgrade, which is normally in configuration management terms a couple of seconds of upgrades, now takes a lot more time just to deploy to production. So I still see definitely a use case for configuration management, and we've been using it in very tiny ways. Like our current code base for Elastic as a Service is only 2,500 lines. So basically we drop YAML directly to JSON for configuration of Consul and Nomad because they support JSON, and other types of configuration which have different DSLs, we just drop them as raw content directly. In the situation we're in right now, I render our Nomad job files in SaltStack. The reason I do this is because it makes it a bit easier to deal with environment specifics instead of coding it myself based on metadata. And for now, I don't feel a need to start building a self-service API which actually does this. I just don't feel that there's too much return on investment. The way we've been doing it right now is very quick. Everyone knows how to do it, and maybe at some point when more people were willing to start using this, and we can consider building some self-service API. But for us, this is good enough right now. So obviously, I showed the Let's Encrypt certificates for Fabio. For SL termination. SaltStack actually has a module which plugs into our built-in in-house product EasySSL. It calls out like every run, like I need a certificate for these domains, and then EasySSL checks if the current one, if there is one. If there's not, it starts requesting one. If it's about to expire, like a week from now, it starts renewing, and then next run, SaltStack drops the files in SSL folder for Fabio. Fabio can automatically reload every couple of seconds, those SSL certificates, so that's fairly low maintenance, pretty much none. So that makes our life a lot easier. So going back to, now you got an overview of how things work. Going back to the demo. And then take the Fabio routes. Just to show, like now you have more experience, like you see the role of Fabio in our setup, and you'll see the routes in there, which means Nomad schedules the service, assigns a dynamic port, endpoint comes up, Fabio creates the route, and obviously for production use cases we have a couple of hundred of these routes. It scales very well. So far we've been, pretty happy with it. From a Terraform perspective, when we start out a new cluster, you obviously need a way to tell configuration management, like what is your role? Like how do you deal with setting up your own, identifying a role, setting up configuration for you and whatever. The way we've been doing that is using metadata. So as you can see, you saw in the demo, I did a make apply and specified the Git repo. That's basically an environment variable which is set as metadata. That's how we instruct the salt master. Here's your configuration management, go clone, start bootstrapping, and then run the entire stack. So that's pretty much it, like from a technical perspective. I wonder if there's any questions, like anything special to ask. Yeah, sir. Oh, sorry, wait for the mic.
I was curious how you deal with loss of data nodes. Do you allow the data to be migrated in the sticky volumes, or do you just deal with the loss of it in the case of a loss of a node?
So, good question. The thing is, like, if you lose a data node, or basically a worker, that means, then you're probably going to lose the data anyway. Even though you might enable migratable volumes or migrate data from Nomad, you don't have anything to migrate from. Obviously, ElasticSearch already provides resiliency for this. You have to make sure that you distribute your replica shards across the availability zones, so you always have the redundancy in ElasticSearch. So you don't rely primarily on Nomad to provide that functionality. We just rely on the fact that we want to make sure the data doesn't disappear if you stop a job. That's pretty much it. Yeah. Any other questions? Anyone interested in running this in their setups? Yeah.
Actually, I do have a question. Is any of this open source that you've done?
Yeah, well, so question was if this is open source. Obviously, everything I've been using in here is open source except for the commercial license of the security in ElasticSearch. This is basically more like how did I build this using existing tools. So I can obviously share this with the community and share the job files and how I've set it up and how this is tied together. I just haven't so far because we've been running private cloud using OpenStack. So it's not easy for me to just like share what I already have. I can build it obviously fairly easy for AWS. So if there's interest, look me up after and I'll see what I can do. Cool. Anything else?
How does Nomad help with the rolling upgrade?
Okay, so the question is how Nomad helps with upgrades and rolling upgrades. Nomad doesn't do much in rolling upgrades for us. So obviously the .6 release introduced the canary releases and rolling upgrades. But in this case, for upgrades, we smash an entire availability zone. We rely on the fact that we have shards distributed across all availability zones. So we don't have to account for the fact that we do per instance upgrades. We can just throw out an entire availability zone, upgrade that one, go on to the next. And that can be done in any kind of way. You can script it with the API, you can script it through shell script and Nomad CLI. There's a ton of ways to do that. Anything else? In the back.
I have a question in terms of ElasticSearch discovery.
Mm-hmm.
As you know, in the new version of ElasticSearch, you can actually point to the actual DNS name, which resolves to multiple flows.
Yeah.
And I did that, and it works fine. So I was wondering what's the difference between using that console discovery plugin versus this?
So the question was, what's the difference between using Consul discovery plugin native compared to just a DNS lookup? Maybe even from Consul a DNS lookup, or?
Yeah, Consul.
Yeah. So the difference is the port, right? You can specify a DNS address, but that doesn't contain the port where the node is going to run on. And obviously this all runs on dynamic ports, so you can't predict that. So what Consul Service Discovery, the plugin enables us to do is fetch all the service information from Consul and connect directly to the correct port. That's the rule. Anything else? No questions? That's it. Cool. Thank you.